Wow. Hello, everyone. How are you? I think you've got a little bit of energy right now. Um, Thanks so much for being here today. I am Minerva Tantoko, and I am not a robot. How many people had to prove they weren't a robot today? Yeah, pretty much. A couple times, anytime I have to log into something. So I'm telling you right now that I'm not a robot. So my name's Minerva Tantoko, and class of '86. And first I want to thank, of course, Vassar College and the organizers who've been so incredibly helpful. Willa and Jeanette and Stacy and Wesley, thank you so much for making me feel welcome. And while I appreciate what the robots wrote about me, I'm excited to personally share with you my journey from philosophy major to technology leader and AI patent holder. Most importantly, I want to explore with you why I believe a liberal arts education is more crucial than ever in shaping our technological future. So with nearly 4 decades in enterprise technology, as a startup founder, a pioneer in mobile, AI, data strategy, I served in executive technology and product management roles at Merrill Lynch, UBS, Palm, and was appointed the first ever Chief Technology Officer of the City of New York. You might have heard of that place. Where I founded and directed the Mayor's Office of Tech and Innovation. And as CTO of New York, I launched initiatives in smart city policy, government tech like Link NYC, Computer Science for All, Internet of Things guidelines, and after City Hall, I founded a bank, as you do. I founded Grasshopper Bank, the first digital commercial bank, a de novo, meaning it was not a bank before, it was a completely new charter. The first to get a charter like that in over a decade. And I'll let you in on a little secret. It's called Grasshopper Bank because I wanted to pay an homage to Grace Marie Hopper. I was hoping to call it Grace Hopper Bank, but I thought, I'll have to get permission, and it's not really affiliated with that person, but so we called it Grasshopper, and it's doing well. If you're doing a startup or you're a venture capital fund, bank with Grace Hopper Bank. And today, I'm an entrepreneur, angel investor, and I consult on AI strategy, IoT, Internet of Things, and FinTech. And I majored in, anybody want to guess? You probably know, philosophy. Makes perfect sense, right? I've had a front row seat and sometimes even been on stage at some of the most impactful technology transformations of the past 4 decades. The personal computer, the internet, mobile technology, financial tech, and all throughout, artificial intelligence, which actually got me started here at Vassar. Yes. In hindsight, this journey makes sense. But to quote Steve Jobs in his speech at Stanford in 2005, which was like 10 years after I graduated, but this quote means a lot. I'll read it to you now. You can't connect the dots looking forward. You can only connect them looking backwards. So you have to trust that the dots will somehow connect in your future. You have to trust in something, your gut, destiny, life, karma, whatever. This approach has never let me down, and it has made all the difference in my life. And that was Steve Jobs. So from the perspective of starting at the beginning, how did my dots start to fall into place? Well, if you take a trip back to 1982, it was the year that Diet Coke was invented. It was the year Bud Light was invented. I don't know if that was such a good year. And the latest and greatest technology was the Sony Watchman, which was a portable TV that weighed about 10 pounds. And the personal computer of the day was the Commodore 64. And the most advanced supercomputer was something called a Cray XMP. So just to give you a little comparison, in the 80s, a Cray XMP reached a peak performance in the range of 800 megaflops. Okay, what does that mean? Well, a flop is a floating point operation per second. So that's operations, how much math can it do in a second? A Cray could do 800 million of those. That's pretty impressive, right? But a current NVIDIA GPU can achieve many teraflops. That means trillions of floating point operations per second. Back then, a Cray cost about $15 million. Good to have that kind of allowance. But today, an NVIDIA GE Force 3070 costs $399. So you went from millions to trillions. Let me ask you something. How many of you here think you're smarter than a computer? You should all be raising your hand. Yes, correct. Because the most powerful supercomputer today, it's called the Oak Ridge, something or other. It is maybe on a good day can do 1 exaflop. We have to keep up making words, right? Making up words. An exaflop is a billion. That's 1 with 16 zeros. Okay? So your smartest supercomputer is about an exaflop. It would take a football field size space of servers, and it would use 25 megawatts of power. The human brain, about 8 exaflops. It fits in this handy little skull, and it takes about 25 watts of power to run. So yes, indeed, you are all smarter than any computer. There was a recent article by Turing Prize winner, Professor Jan LeCun. He was my colleague for a little while. He put out an article that said, their smartest computer is about as smart as a cat. But I think that's an insult to cats. So in 1982, when I entered Vassar, I had all the dots planned. I knew I was going to be a doctor. I had plans to focus on pre-med, major in biology, get into a good med school, blah, 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 because that was my path. Little did I know that a decision to study at a liberal arts college would become the foundation of my career in tech. So my journey into tech began unexpectedly. As part of my interest in brain science, my studies in cognitive psychology took me to the computer center, otherwise known as the laundry building, where the mainframe computer gave me access to a statistical program. I know, and when I told my parents, well, I'm studying computers in the laundry building, they were super confused what was going on up here in Poughkeepsie, but that was required for the psychology class. So once I touched that keyboard, I knew that my life had changed. I thought it was so cool that I could type into a machine and it would do things and give me answers and calculate. And later I would learn I could quote unquote teach it to think. The next important dot connection happened when I was visiting a former Vassar classmate in the summer of '85. This was junior into senior year. And I met 3 people in Silicon Valley. My friend from Vassar had joined them to see if they could help, and they were on a mission to use AI to automate and create an expert system. And that is how I got involved in my very first startup. So Silicon Valley in the 80s was a sort of mythical, magical time. I happened to be there visiting. I met these guys starting an AI company. I was like, well, I know AI, And it turned out, it led me to become one of their first employees. And that startup became a successful Silicon Valley startup, which we sold 5 years later. I got to meet really wonderful people, and I learned some important lessons along the way. So lesson one was, just because no one's ever done it before is not a reason not to do it. It just means you'll be the first one. And so I stayed through the summer and then skipped my fall semester. I'm not saying do this, I'm just telling you what happened to me. And at that time, it was not done, people leaving college to start companies, but I did create the product education, was probably the first ever product manager. I think I can probably claim that in 1985. But then I did go back to Vassar in the spring of '86. I had enough credits to do one more semester and write my senior thesis, and then go back to the startup. Interestingly, I had other opportunities when I graduated. I had offers from Wall Street, I had offers from a big tech mainframe company. But I decided to go back to the startup because it was such an interesting group of people. They were also well-rounded folks, also diverse. One had just finished their degree at a divinity school. And, I enjoyed the intellectual challenge of what we were trying to do. And I thought, now's the time to figure out if this crazy idea is going to actually work. So how did my liberal arts degree translate into this? By my junior year, I decided to pursue my interest in brain science, but not necessarily go to medical school. Someone else could be a brain surgeon. I was really interested in designing systems that could help us learn about the brain. And when else would I have the freedom to explore and pursue my intellectual interest, my curiosity? And so I decided to major in philosophy, which I really enjoyed. And could I somehow turn that into the study of the mind and the brain? And one of the great things about Vassar is it offered an opportunity to create a major. This was before cognitive science was even a major, so I think it came in a couple years later. And after my time in the startup, I returned to Vassar for my last semester, wrote my thesis. And my thesis, which I recently got out of archive recently, it was on the theory of subjectivity in machines. Can computers have emotions? Which again, for '86 was kind of cuckoo, but now not such a crazy question, right? Something told me during my time in Silicon Valley that the world would be changed forever. The personal computer was now putting computing power on everyone's desks. And I didn't know where this path would lead. I didn't know where the next dot was going to be. But since I was among the first people to think about it, that also meant I could help define the path. I didn't know where that next dot was, but maybe I could actually be the one to put the dots there. So at my startup, I was not a programmer, even though I was programming in school. The liberal arts piece of it actually made me a much more valuable part of the startup. I did programming classes at school, but I was one of the first product managers in the industry. My job was called knowledge engineer. And what that meant was I would translate human knowledge into something computers could do. I think we call that, product management now. But but at the time, it was knowledge engineer. We were going to instill knowledge into a computer, and I was going to engineer it. And so what I gained in my Vassar education were the important skills. I didn't realize at the time, but I used them immediately. Critical thinking, design thinking, problem solving. Liberal arts taught me how to analyze complex problems and break them down into their constituent parts and approach them from multiple angles. This skill is invaluable in the tech world, where we're constantly faced with new challenges that require innovative solutions, things that did not exist before, and invent and imagine the answers along the way. Just as a side note, I once had to do, one of my projects in my first startup was to create a budget for building the Channel Tunnel, which is the tunnel from London, between London and Paris. And it's like, wait a minute, how do you do that? I was using my AI program, but it was literally figuring out how much would it cost to bore a hole through the English Channel, and how much would these drills that don't even exist yet cost. And by the way, the euro was supposed to happen in the middle of all this, so how would you even calculate the cost in pounds and francs, and then convert them later? So all of that confidence to address the unknown, I can credit directly to my training here at this wonderful college. So once we sold the startup, I once again was on a journey to find the next dot. And as it happens, while I was in the startup, the first Macintosh and graphic interfaces were being invented. We used to do things on paper, and we used to, PowerPoint slides are called slides because they used to be actual slides that we would color in. As you know, I studied studio art here, art history, and I was confident in the concepts of design, and I was teaching myself how to use a computer to do like page layout and stuff. And so I said, well, now I've sold a startup. I'm 26 years old. Now what do I do? And so I sent my resume out, and someone who read it was another classmate from Vassar who happened to be in publishing, and said, well, we're looking for, an editor, managing editor. And that was right at the cusp of people starting to use computers to process words and then also design things with the computer. And so once again, I found myself at the front row seat. I started out as a managing editor for Architecture and Interiors magazine, got the computers to do writing. I was emailing, fancy, back and forth with the authors. And then over time, actually helped convert all 22 magazines, which were all owned by Billboard Publications, from manual to electronic publishing. So once again, just forging new dots. Over the years, my toolkit from liberal arts has been a huge advantage in forging my path. As I mentioned, critical thinking. Philosophy taught me to analyze complex problems. Ethical reasoning. As we delve deeper into the age of AI, ethical considerations are becoming increasingly important. My background in philosophy and general humanistic approach has been crucial in navigating ethical implications of new technologies. So for instance, when I work on AI applications, I always consider questions like, how do we ensure this AI is fair and unbiased? How is it effective? How do we protect privacy while leveraging the data for innovation? From liberal arts, it's a broad-based learning. Liberal arts education exposes you to a wide range of disciplines, from literature to history to science, and they're all smushed up against each other. And it is in that juxtaposition that you find the sparks of innovation, connecting two disparate ideas and thinking of new ways to combine them. And these philosophical questions require that level of deep critical thinking. Interdisciplinary collaboration was another key part of my secret sauce. I was able to talk to the artists and the engineers and the musicians and the mathematicians and figure out how we could all work together across all these disciplines to create exciting new things. So the person who can bridge that gap between technology and all those other disciplines, be that translator, the human translator for things, anthropology, psychology, environmental science, public health, all those things, when combined, make a more humanistic future for all of us. So I want to make sure we have time for questions. I'll close now. I do have some top tips, which maybe I'll give you a little later, but I think the key part of my message tonight is the future needs humanists. The title of my talk was Humanist Ex Machina, right? So in the same way that the Greeks would say, oh, well, the God will come and solve everything, and they get lowered down on stage, we now live in an age where we need the humanists to come in and help solve everything. We've gone through a few decades of, first we had internet natives, people who were born, never knew a world without internet. Then we had people who were born, never knew a world without mobile. Now everyone born will never know a world where AI is not part of every single facet of your life. And so AI natives, more than ever, need the humans to control. So as we stand at the cusp of an AI revolution, the skills developed through humanistic studies are more relevant than ever. We need minds trained in philosophy, ethics, and critical thinking to ensure that our technological advancements serve humanity's best interests and not the other way around. We need to embrace the humanist advantage in tech. Technology doesn't exist in a vacuum. It's shaped by and for humanity. Your ability to think critically about the ethical, social, and cultural implications of technology is invaluable. And as AI and other technologies continue to evolve, we need minds trained in the humanities to ensure that we serve humanity. AI is going to automate many technical tasks. In fact, one of the things that we talked about at the Women in AI Summit last fall is that AI is not going to take your job. Someone who knows how to use AI is going to take your job. Very important to be AI literate, no matter what industry you're in. The real value will lie in leaders who can navigate the nuanced human and ethical dimensions of technology. And we need people who can think critically about the implications and who can communicate complex ideas to diverse audiences and who can ensure that our advancements align with human values. I'll close with another one of my favorite quotes from William Gibson. The future is already here. It's just not evenly distributed. So as we move forward in this age of artificial intelligence, engineers skilled in designing intuitive interfaces and interactions between humans and intelligent systems will be highly successful. But more importantly, we need thinkers who can question, analyze, and shape the very nature of these interactions. The future of technology needs your liberal arts mind. It needs your ability to ask not just can we, but should we? And how can we do this ethically and inclusively? That is the power of the humanist in the machine age. So embrace your liberal arts backgrounds. Let it be your superpower, just as it has been mine. Use it to shape the future of technology in ways that are ethical, inclusive, and truly beneficial to society. In a world increasingly driven by technology, it's our humanity, our ability to think, reason, empathize that will make all the difference. And that's exactly what a liberal arts education prepares you for. So go forth and be a dot connector. Thank you. Now I know you, come on, you've got some burning questions for me. If not, I can keep talking about boring things. Anybody? Yep, there's some mics there. Excellent.
Hi. How do you recommend for people that aren't necessarily going into the tech industry that we expand our AI literacy?
Great question. So how many of you have experimented with any one of the large language models, ChatGPT, Claude? Yeah. So that's a good start, actually. Just playing with it, trying it out. I mean, for all, part of my role was to try every new thing. I have had some of the earliest accounts on, I think I have the first AOL account, I literally had Minerva at AOL for years, and just playing and learning and understanding how things are, but also keeping in mind that, it can hallucinate, as, the robots sometimes give me a sister I didn't have, or, a degree I didn't have. So I think what's important to keep in mind is to, try out things, but with some guardrails. I'll share with you one quick story why literacy is so important. So in the early days of the internet, there was this new product called MapQuest. So it was built by people who hated stopping and asking people for directions, and they didn't have a map. So what they would do, you would go to the interwebs and you would type in where you were. It would give you directions. You would then print those directions, bring them to your car, and try not to hit anything while you were simultaneously trying to read these directions, because otherwise you would have to get a map from AAA where they do that for you by hand. But in the early days, what happened was people were following the directions, which may or may not have been correct, and literally making a left turn like into a river, or making a right turn into a ditch. And when asked, they were like, well, that's what the computer said to do. And I'm like, well, my concern with the lack of literacy is that people will ignored the visual cues, like, hey, that road is closed, or there's water there, and so I think, a part of the goal of literacy is to really understand that at the end of the day, it's not up to the computer, it's up to us, how we use it, like any tool. I mean, how many of you have had spell checker give you the wrong answer, right? Yeah, because it doesn't understand the context. It may be correctly spelled, but doesn't make sense. Just did that to me yesterday. 2 words would have fit, but from a spelling perspective, but it didn't make sense in that context. So I think AI literacy is not just about being a consumer of or user of, but a director of those tools. Great question. Oh, we got one up here. Yeah, there's a mic over there.
Thank you. I work in the nonprofit industry, and if you know nonprofit, they're not always really the best with incorporating technology into things that they don't understand it should be incorporated into.
Mm-hmm.
Do you have a strategy for approaching industries that maybe are not so tech savvy and saying, hey, here's how you can do this, and here's what it can do for you?
Great question. So I have 2 answers for you. One of the reasons I decided to join the City of New York government, when everybody else told me, like, why would you do that? You're a CTO of the world's largest bank, and you're doing pretty well. It was in part because I saw that there was a lack of technology knowledge in government, and that, the effective use of, databases and social media and, internet would have a massively leveraged impact, right? And so I think there is a movement amongst technologists to say, where can we apply this where it can have the greatest impact? There's actually a group that I'm part of called CTOs for Good, and it is the nonprofit CTOs all get together and help each other. And I think that is a specific challenge because it's not like a private company that has a gazillion, dollars to spend. But at the same time, you might find that there are ways to get funding, to use technology more effectively. I was just talking to a nonprofit the other day that, they wanted a simple tool that would help match, mentors with mentees. And that's a manual process today. I've seen, particularly with Gen AI, I've talked to another generative AI, which is what the large language models do. They are thinking about using AI to help them generate grant proposals. But keep in mind that some of the foundations might be using AI to read your proposals. So the robots talking to robots. I don't know how well that's all going to turn out, but you know, it could help save time, right? And where you might be short-staffed in an area, maybe in research or being able to review or even just find the grants that are applicable, right? Here's what I want to do. Where are the grants? You know, that is something that AI could be very well poised to help do. So I think there are opportunities, but they have those specific challenges for sure. Great question. Okay. Hi.
Hi, this will be a little bit of a follow-up on the not-for-profit question. I work in government, specifically in New York State government, and there has been a suggestion that algorithms in use in state government for purposes of applying benefits decisions or maybe parole decisions or other large decisions that affect people's welfare are inherently unfair and have factors or fields of data feeding the algorithm that may be subject to typographical error or manual user error. How do you ensure that we inject fairness into algorithms that have a direct impact on people's lives? Because I hear you say that there are, you know, you need to be a humanist in order to ensure that you're building these algorithms properly, but most often we see that these algorithms are aimed at efficiency. I'll use that word, the lowering of costs, especially when it comes to government benefits and other types of government resources.
That's an excellent question, and something that, you know, I've been focused on in some of the research I did as Chief AI Officer at McSilver Institute for Poverty Policy and Research. And it was specifically around those questions of AI and equity and what tools can we build to help do that, given that the data that's being used to create these patterns might already be biased, and they are, okay, it's been proven. What can you do? So we took a couple different approaches in our research, and that, you know, hopefully it'll be winding up soon. But part of the grant, one of the grants was, you know, how do you even detect bias in a body of data? And we compared actually 6 different quote-unquote fairness algorithms. Some were statistical and some were machine learning, and then we compared how accurate it was in terms of, you know, geographic distribution or racial distribution, gender distribution. This is in the public health data from the CDC, right? So we took a public data set, and then we employed multiple algorithms to cross-test which would be predictive and which would be incorrect based on those. And then the next step was, and there were areas, because it was, you know, the data we were looking at, high school students' mental health, a critical data set. There were actual differences that we found between groups of ethnicities and so forth. Then the next piece was, okay, how do you correct for that? And there are tools out there that actually are, you know, they're called antagonistic algorithms. I think I'm calling them correcting algorithms, which is a way to then, how do you balance the data? Now you've discovered, you know, empirically that there are differences in the data. How do you then balance it and correct it through machine learning? And then the next step is, once you've done these predictions, to make that loop back to say this was correct, this was not correct. And so much of our usage right now is this black box approach, where we only know what comes in and we only know what comes out. And what I'm saying, well, if you're putting garbage in, you're going to get garbage out. And it's been proven time and time again in health decisions, sentencing decisions, in, you know, and it's also, what do you choose as the proxy for that data? So in the sentencing decision, they measured recidivism, you know, your likelihood that you'll end up back in jail based on whether you were arrested or not. Well, we know that certain kinds of people are arrested more than others. It doesn't necessarily mean they went back to jail. So they actually just picked the wrong factor to optimize against, right? But someone has to sit there and go, that doesn't make sense. Like, instead of starting to give people longer sentences, right? Same thing for certain healthcare decisions. So, I'll give you one other example, because I'm a little, I've got plenty of outrageous examples, but here's one that's pretty simple. It just required some critical thinking. It was a program to, that doctors' offices were going to use to reduce people's missed appointments, right? So if you missed your appointment a few times, it would like predict that you were going to miss it and then double book that, appointment. And guess what? That had a disparate impact on A, people who were hourly workers, because for whatever reason they couldn't get that time off, or B, had to travel further to that doctor. So and then when they did show up and the computer was wrong, they ended up having to wait because that appointment got double booked, right? So it's being that annoying person in the room, that's all your job now, to say, wait a minute, I need to be annoying now and ask you, did you check to see that this was actually working in the way that you expected it to work? So, we've got a long way to go. And I think there's a lot of like unthinking, shoot first, aim later kind of approach to these black box, algorithms. And that's why I think knowing your ability to have agency and your rights will be very important. And another important, New York State and New York City, the law against, algorithmic bias in hiring decisions. That's the easiest one, right? All the early ones would do is it would look at all the resumes of the people that already worked there. It would discern a pattern. And then if your resume fit that pattern, you were going to get an interview. Well, guess what? If historically everyone in that job, particularly tech jobs, it was really mainly tech companies that used these algorithms in the beginning, came from a certain level of school, had male-sounding names, had engineering degrees, well, guess what? If you didn't go to one of those schools, had a philosophy degree, and had a name that ended in A, you were not going to get that job, right? You weren't even going to get the interview, right? So there's a lot of adjustment to be made. And what I'll say, on this one topic, because now you got me going here, is you can't throw an algorithm in jail, right? So the laws apply to people and to computers. So if your computer is discriminating, that's still against the law, right? If your computer is, defrauding people, that's still against the law, right? And so, well, at a certain point, we need to say, well, you can't say, oh, well, the pharmaceutical company didn't kill those people, it's that drug that's so bad. But it's like, well, yeah, but you sold the drug and you created it and those people took it. So eventually, right, accountability will catch up. Great question, though. And I could talk for hours on that. All right, I think we have, time for a couple more. Hi.
So I know that the U.S. Copyright Office statement on generating stuff with generative AI is that the AI owns it, and since AI is not a human, it's uncopyrightable. And so in using generative AI in daily lives and integrating it, how can you really use it in ways, since anything it helps you with is not yours, it's not the company's, it's out there?
Well, there is, you're right. I mean, but there are many ways that you can get assistance without requiring it be authored or copyrightable, right? So the things that I've seen people make a lot of use of it is, and I love this because, you can point, you can train or point to a large language model against a big body of knowledge, whether it's research or policies and procedures or, I was just talking to the American Bar Association yesterday, and it's like, okay, well, summarize those decisions. I'm not trying to copyright the output of it. I just want to be able to read, a couple 100,000 documents in 5 minutes, right? And then with RAG, which is the retrieval augmented version, if you pre-process it, it'll not only give you the summary, but it'll give you a link to the originating document where it got that information from. And, I think that's the kind of thing that I think over time, generative AI will be helpful for. And, it's really a human interface thing. It's not, it really goes right to the question of how do I access information versus I need to another Shakespeare, to come out of this machine, right? So, yeah, I did, by the way, when ChatGPT came out, I was like, oh, just as a joke, I was like, oh, write me a Shakespeare sonnet about the Big Mac. And it did a pretty good job, to see what it could do. But it's not like, that's something I would specifically want to do. Thanks, Brendan. Okay. Next question. Oh, we'll perfect. I think this will be perfect for the time we have left. Okay.
Hi, Chris Deutsch, class of 97, and a fellow angel. I don't know too many Vassar angels, so it's fantastic to hear you are one as well. As you know, as an angel, a big part of what we do to try to help our founders is find talent. Got a lot of awesome talent in this room that we're going to be trying to help this weekend. And I'm curious if you have any pointers for them in how to stand out when they're going and looking for a job, whether it's at a startup or not. There's a lot of noise, and how can they break through that noise as the signal?
Yeah, it's so interesting because you would think that, venture capital or even angel investing would have been automated somehow by now, but it's not. It's still very much a people-based thing. It's a who you know networking thing. And, where I've, and it's really a long process of cultivating those folks that I've known now for 4 decades, some of whom are, when I put together my bank, for example, I wanted to assemble people who had never worked at a bank before, but were really good at customer user interface, customer service, and then people who had spent decades in banking, who understood all the regulations and rules, but were willing now to join a startup bank, right? So a special kind of crazy, and so I think as an angel, I think what you can do, for those of you, an angel investor is a very, very early, pre-seed stage investor in a company where it's really just an idea and you want to help with this, compared with large VC, Series A funding. It's a very small startup amount of money. And yeah, finding talent is that. I also think that, there's a lot of, and you're probably in it, like New York Angels and other groups, but, there are ways to break through by being part of these networks, I guess I would say. I hope that helps. We could talk about it more later. Okay, next.
Hi there. Just circling back to the issue of bias in AI, there are countermeasures that you've mentioned for attempting to remove it from data sets and get AI to produce more ethical outcomes, but there's no requirement for those to be implemented. And even if you have a person in the room who is being annoying, like you said, you're not going to have that everywhere. And ultimately, companies exist to make money. So the ultimate trend is going to be for that to be circumvented, and if AI is able to come up with a solution that produces more money but hurts more people, then that's going to be more attractive to corporations, just inherently. So why should we as consumers and as citizens be willing to put up with that risk instead of working to remove AI from the decision process altogether for certain sensitive areas like the ones you mentioned earlier, healthcare, mental health, etc.?
No, I think this is the quandary of our time, and especially now where, look, I think there is a role, having been in government now I do understand the role of regulation in protecting consumers. If it didn't exist, the consumers would not be protected. People would not, Capital One just paid a fine for not paying their their customers the interest that they were owed. Literally, like by law, they were owed billions of dollars in interest, and they were like never paid it, right? So, so the role of regulation was like, hey, you owe them that interest amount, and I think if you're right, efficiency is actually not what we should be optimizing for. We should be optimizing for outcomes, right? So yeah, I mean, if you ask a computer, what's more efficient, probably it's it will make a decision based on the cost of a certain level of care versus finding the level of care that will actually help that person live, right? Living's always more expensive than not living, right? So, so like that level of logic, that's why the humans have to be accountable for those results. I think part of the thing is apply existing laws, apply existing human accountability. You don't get a pass by saying, well, the computer did it. I don't think it's possible to put the genie back in the bottle and say you can't use AI, but if you can make people accountable for those outcomes, then it'll be on them to make sure that they don't get caught discriminating or get caught, with lower and lower poor health outcomes. Does that make sense? I don't think we can just outlaw it. That's just that ship has gone. Okay, 2 more, and then because I know we want to get moving to the next event. Okay, I'll be quick.
Hello. There's been a lot of questions brought up about the outcome of AI, but there's also the operation of it, especially because it's very high, like energy usage, especially of water. So how do we combat the environmental concerns of AI usage?
Yeah, that's a massive concern. As I pointed out, there's a difference between 25 megawatts and 20 watts in your brain. I was at a recent UN General Assembly meeting specifically about this, because what it also means is that who's going to be able to get the AI electricity that everyone needs? Where's that water going to come from that runs all of that? What is going to be the environmental impact of all of that? And so I think right now there's definitely consideration and movement back to nuclear power, however you think about that. There's also a real awareness both at the international level and at the corporate level. There were 3 of the major AI providers at this discussion to talk about how we can actually come up with a more energy efficient kind of technology. But yeah, that is brought up at every meeting. I think, no one has the answer yet, but is absolutely on the agenda of not just, places like the UN and the EU, but also the major companies who are using the energy to compete.
Hi. I'd like to know what your personal definition of artificial general intelligence is and what your prediction is for when it comes out, and also about the future of work. So certain classes of employment we know probably won't be automated, like politicians and athletes and kindergarten teachers, but like maybe in 5 years what jobs will exist, and in 10 years what jobs will exist. And also for students who are interested in going to technical alignment work, how can they apply like the critical thinking and the liberal arts skills you just mentioned in their field?
Well, that's a lot of questions in a row, but I'll try and cover them quickly. One is, I've invented every job I've ever had, and maybe in 10 years the jobs I've had won't exist anymore. I think, that level of flexibility and understanding what needs to happen is not like something you train for. It is something that you learn how to learn. It's how I've kept up with everything. I learned how to learn here, and so I've learned new computer languages. I've gotten certifications. I've added to, I just got a certification on AI and human protections. And I'm like, why not get a license in that? Okay, so but it's good to have it, right? And I think that's going to be the modus operandi for anyone entering the workforce, is to constantly learn, constantly adjust, and invent your next job. What we thought were jobs before may be less important now. So maybe you needed to be a really good coder, but now you're going to be the person that can tell the coding software what to do. That's a very different type of thought process, right? How can you integrate it and so forth. So it's an exciting world. There's dots yet to be put on the map. All right, well, I think we're at time, but I will be around. Obviously, we have this lovely reception. What did you all think of this talk? Was it okay? All right. I have some helpful hints for liberal arts majors going into tech, so, feel free to hit me up then. Thank you.
Just a couple of quick housekeeping items. Sorry. I know you're ready to go to a reception or to go to Gordon Commons. So first I just want to say thank you to all of you who asked questions. They were so thoughtful. I want to encourage you to keep asking questions and keep being curious this weekend. That goes for students and mentors alike. So where are you going next? Mentors. You are headed to the Bridge Building to reconnect with faculty and administrators who are hopefully there, eager and waiting for you. Students, it is time for dinner, but let me announce this caveat. Gordon Commons is open and expecting you, but they may not be expecting all 260 of you at once. So if you need to make a pit stop on your way to Gordon Commons, feel free to head back to your room, drop off your bag. Basically, don't all rush there en masse. The lines will be better, the staff will appreciate you, and we look forward to seeing you again tomorrow, students. Have a great night, everybody.